Hello, once again. Now that on the previous lesson we looked at the previous two lessons for the linear inequalities, we looked at the basics of what inequalities are and how do we deal with the negative multiplication and division and the transposing or the adding and subtracting of a number in inequality. So now we are equipped to deal with more problems, so we can have, in addition, the compound inequalities. Compound inequalities are inequalities with more than one, with actually more than one inequality sign. Okay, so then now for that we can have the compound inequality. We're talking about example inequalities of this kind: -3 is less than 3x minus 1 less than 5. So our variable is between two inequality signs. Alright, so then now we can write the solution to this and also represent it on a number line. So what we do is you can separate the two. For instance, you can have this part here and you can have this section here. So you separate with an and then you put them together afterwards. So taking down that section, we're going to have -3 is less than 3x minus 1. So then now to solve this, we know that actually we can transpose and doesn't change the inequality sign. What we can do is we can, both sides we can remove 1 and then we can also go on and solve our inequality. So we're going to have -3 plus 1 is less than 3x. So we end up with -2. We end up with -2 is less than 3x. So then now we can divide both sides by 3. Since we divide by a positive number, we don't reverse the inequality sign. So we end up with -2 is less than x. So we can put this properly. Reading it from right to left, say x is bigger than -2 over 3, or we can just write it as x greater than -2 over 3. So this is still our old inequality. Actually, we didn't reverse anything, we just changed the way we read it or we write. So then now we have this, and also blue one, we have 3x minus 1 is less than 5. So again, transposing -1, we end up with 3x is less than 5 plus 1. And then we go on to solve this and say 3x is less than 6, and then dividing both sides by 3, end up with x is less than 2. So then now putting it together, we then going to have x. Remember, it must be bigger than -2 over 3, but less than 2. So representing this on a number line, representing the solution on a number line, we're going to have -2 over 3 smaller than 2, so it's not coming first, and then since there is no inclusivity, then we put the open circles, and then we say x is between these two numbers. It's bigger than -2 over 3, but less than 2. So this is our representation of our compound inequality on a number line with its own solution. So we can go on and have the number line for the first two. We have -2 over 3 on a number line, since the open inequality is supposed to be bigger than that, so it will flip in the direction. And then the other one, since it's 2 is less than 2, we have an open circle and then going down that direction. So these are the two inequalities put together, they give us this. They're supposed to go to the left and to the right at the same time. So it means that it's between two numbers. So between the two numbers, any value between -2 and -2 over 3 and 2. So this is how we solve the compound inequality. We can have one more example. We can have one more example where we can, this is our B. We can have -2 less than 3 minus 1 over 2 x is less or equal to 5. Then again, solving this, we're going to separate the two, where we have everything on the inside and the left hand side of the equal sign, as well as everything on this side. So solving this, we end up with -2 less than 3 minus 1 over 2x. So solving this, we have to transpose. So what we're going to have, we're going to say -2 minus 3 is less than -1 over 2x. Transposing doesn't change the equality sign, so we don't change the equality. So this ends up being -5 is less than -1 over 2x. Okay, so then now continue with this. We're going to multiply both sides by -2. Multiply both sides by -2. We'll end up with 10 here, and then it will be bigger because multiplied by a negative number. Bigger, and then 2 cancels 2 there at the bottom, and negative times negative is positive, so we end up with positive x. So therefore, we can see 10 is bigger than x, and then x is less than 10. And then with its own number line, we end up with 10. If x is less than 10, so anything below 10. That's our number line for the solution. And we also have 3 minus 1 over 2 x less or equals to 5. So we end up with -1 over 2x less or equals to 5 to the minus 3 as well. So -1 over 2x less or equals to 2. So then now we multiply once again by -2. Multiply once again by -2. So we end up with 2 cancelling 2, and negative times negative is positive. And we have positive x is less than 2 times 2 is 4. 2 times negative is negative. So x is different. Sorry, it's not less than. We have to change the unequal sentence to multiply by a negative. So because of that, I also forget this. So just pay attention. Don't just cruise and forget the process. So we change the sign because we multiply by -2. So there is x is bigger than -4. So on the number line, we have -4, and then since we have inequality there is greater or equals to -4, so we're going to shade it straight over, and then this must be bigger or equals to, so it must go to the right. So the combined inequality, we have horizontal line. So the lowest number here is -4, the bigger one is 10. Then at -4 we have a shaded part, and then at 10 we have an open circle. So this value says that it is less than 10 but bigger than -4, so between these two values, including 4 next to 10. So this brings us to the end of the compound lesson.